Ngalakin kadijan yung boja.
Okay, let's make a start. Can you all hear me? Can everyone hear me? Yep. Okay. So I'm taking you for LEC 4401, and my name's Martin, if you haven't already had me before, in third year. So if you have any questions on the material or other things, like if you can't make a lab or a quiz or an exam, just send me an email. Also, if you want some time for consultation or a bit of extra time for me to explain stuff to you, then just send me an email and make sure you put LEC4401 in the subject line, okay? Okay, so I'm the unit coordinator for this unit, okay, and I'll be doing all the lectures, okay? But Ali, I don't know if you've met Ali before, he'll be doing all the prac classes, okay? So we'll talk more about the lectures in the prac classes. The prac classes are very important, and it's a good thing if you try and attend them or at least do them online, okay? So if you need to contact Ali, then that's his email address there. Oops. Okay, so the assessment, we're going to have two parts to the course. I'll talk a little bit more about that in a moment. And the assessment's going to be as follows, okay? In the first part, okay, we're going to have 2 labs, okay, and they're worth 10% each, okay. And then you're also going to have a test, mid-sem exam. I'll tell you the precise date of that later, but that's worth 25%. And you'll also have a couple of quizzes, and each quiz is worth 5% each, okay? So that'll make up half the mark, okay? And then for the second part, which we'll talk a bit about, it's on electromagnetism. You don't have labs, but you have one large project to do, okay? And that's worth 20%, okay? And then you also have 2 quizzes worth 5% each, and the test, again, is worth 25% of the total mark, okay? So then that adds up to 50% of the mark. So 50% for the circuit theory part and 50% for the electromagnetism part, okay? Sorry? Yeah, so the test here, or the exam, will be in the exam week, okay? So these, well, I should say exam, not test, but they're like 2 hours each, right? So your standard 2-hour exam, okay? So there'll be one in the first half, okay? It'll actually be just after study break, okay? I'll give you the details later.
Which study break? Yeah, full study break.
I'll tell you in a minute the exact date. But that will test just the stuff on circuit theory, okay? And then you can forget about circuit theory to some extent and focus on the electromagnetism part of the course, and then you'll have an exam just on the electromagnetism part of the course, which will be in the standard exam week at the end of the semester, okay? Okay, so there's 2 parts. There's part 1, which we'll start a little bit on today. That has approximately 18 lectures. It's on circuit theory. So some of you may have done 3021 last year, okay? So that covers the basics. And so what we're doing here, we'll be revising a little bit of that, okay? And then doing extensions on what you had in 3021, okay? I see some people here also did the course 3017 earlier on, so you probably wouldn't have done as much circuit theory background, so I'll probably put up the course notes from the 3021 up on the LMS so that you can catch up on that if you feel you need to, okay? Okay, so and then part 2 will be electromagnetic theory, okay? So that's looking at electrostatics, okay, which is Coulomb's law, magnetostatics, which is Ampere's law, then combining them together to give Maxwell's equations, okay? So Maxwell's equations describe how electromagnetic radiation propagates through space, etc., etc. And we're looking at applying that to antennas and transmission lines and plane waves and a few other things, okay? So you can think of probably the lectures as a bit of just a guide through the course, okay? But you should try and attend practical classes, okay? Or try and do them online at least, because in the practical classes, Ali will go through a lot more problems, okay? And you can ask questions more, okay? So they're a lot more interactive. And if you do that, then, and you do all the exercises in the prac classes, you should do okay in the unit, okay? Coming to lectures is good, but coming to lectures is also important, or at least reviewing the lecture material before you go to the prac class is good, is important, because you get to see the material once, okay, a first time. Hopefully a little bit of it will sink in. If you go to the prac class, you get to see it a second time, and hopefully you'll have some understanding of it after you go through it a second time, and also do some exercises associated with a particular material, okay? I think if you've chosen the online prac classes, then I think you get a link to the Zoom meeting that is for each particular prac class, okay? So I think Ali just sent an email about that around, okay?
You're not done doing it online, do you?
Now?
Because I've got like 50 emails that, what is the Zoom link for the lecture? So they just need to watch the recording?
Yeah, watch the recording. That's Ali, by the way. Yeah, so also these lectures, they're not Zoomed, okay, but they will appear on the LMS as recordings, okay? So that was the question Ali just had, that people were wondering if you could join via Zoom. But at the moment, we're just putting them on the LMS as a recording, okay? Okay, so we also have the 4 quizzes. Okay, so we still have to determine the precise day for the quizzes and the precise time, but they're going to be via the LMS, okay? So in previous years, we did have them in the prac classes, okay, but due to people can't be here because of the COVID-19 restrictions, we're going to have them all online, all at the same time, okay? And we're going to try and find a time that suits most people. I would suspect that it'll probably be in the afternoon after 5 o'clock or something like that, okay, or 6. So to try and avoid any problems with people having clashes with their work, etc., okay? So, but there'll be one time chosen for the quizzes. If you can't make that time, if you've got a serious problem with it, then you should send us an email, okay? And we will try and have an alternative quiz for every quiz that we do, okay? And you know, it'll be sometime after the main quiz, but we'll try and organise something so that you can get a go at having the quiz as well, okay?
So there's no handwriting in the quiz?
No. Probably not. I mean, it may be that we have it so that you write stuff down, you scan it at the end of the quiz, and submit it via LMS. So that was what happened with the exams last year. Okay, but we have to make a decision on that. Okay, so it's possible. So the quiz questions will be some short answers. Okay, and they're based on material covered in lectures in the weeks prior to the relevant prac class, okay, or when it's held. And on the website, you'll also find copies of an informational equation sheet for the unit. Okay, there'll be 2. Okay, I have to check if they're up there now, but they will be by the end of the day. There's one for part 1, okay, which has a lot of formulas that you might need, okay, and you can use, and there'll be one for EMT, okay. So you don't have to remember all the particular formulas, just how to use them, okay. So and during a quiz, that's really the only material you're meant to be using during the quiz, okay. Okay. Okay, so doesn't apply so much now, but basically, you know, after have a quiz, we'll probably go through the solutions to the quiz in the next prac class. But otherwise, we'll be mostly going through examples and answering questions. Okay, and you know, good idea. So before the prac class, there should be the slides will be up on the LMS. So try and have a look at them before you come to the prac class. Okay, and at least so you know what the material's about, and yeah, you can ask relevant questions, okay? I think there's also, I haven't put them up yet, but there has been, in the past, we had some quizzes, online quizzes, because a couple of years ago we did attempt doing all the quizzes online. So I'll look at those and try and get them on online as well, and they automatically marked, okay? You can attempt those, perhaps sharpen your skills up in the particular parts, okay? I think mostly just for part one though. Okay, so there'll be 3 assessments, 3 things that you've got to hand in. There's the 2 labs, okay, which you have to write reports for, and the project, okay? So you have to submit them online, okay? And you know, you can't just hand in handwritten or scanned submissions, okay? So to prepare them, you're going to need, you know, something like Word to write them in, okay? You're going to need some equation editor with that, because you probably have a lot of mathematical equations. You also have to do some drawing, okay? And you'll have to do some graphing and plotting of results, okay? Because you'll be doing probably simulations either in MATLAB or taking measurements in the lab, okay? So you're going to have to plot them up in a nice, neat way and incorporate those plots nicely into the document, okay? So probably you might need something like MATLAB, Octave, or Python, okay? It would be something you could use to produce those sort of graphs and then put them into the document, okay? And the online submissions, you have to be in PDF, preferably with embedded fonts, so that we can print them out and mark them, okay? Okay, so for the first part, okay, there's 2 labs, okay? There's one lab is based on a transmission line, okay? So you have a coil of a coaxial cable, okay? And you're just meant to look at the output of that coaxial cable when you put certain stimulus on the coaxial cable, and also you load it with certain loads, okay? And then write about what sort of model you could make to describe it, okay? So for that, and also for the next one, the second lab's a bit more interesting, is actually making a synthetic transmission line, okay? So instead of having like a piece of coaxial cable to make a delay, you actually use a number of resistors and capacitors to make something that looks like a transmission line, okay? So in that case, you have to do quite a bit of simulation. I'll talk a bit more about that later, and also plotting in MATLAB, and actually making it in the lab and writing up the results, okay? So this week, I think the prac classes are about doing these labs. So it'd be a good idea to try and, even though you haven't really started much in the course, there is something on in the prac classes to just give you some tips about going through the labs, okay? Okay, so yeah, you should read the documents. They're up on the LMS now, okay? I think you're meant to be in pairs in the sessions, especially if you go to an actual session, okay, in the labs, do the lab physically, then you should be allocated to a pair, okay? And you'll be given access to 4 lab sessions, okay? So depending on how fast you work, you might be able to do it in 2 or 3, okay? But there's 4 lab sessions available, okay? You should start with the first lab first, okay? Because that's what the technicians or the lab demonstrator will have that set up, and go through that one. Then you, when you finish that, you can move on to the second lab, okay? Again, you have to submit a report for each lab online, okay, by the due date. There'll also be, now because of the COVID-19 restrictions and people can't be here, we'll also have something on the LMS, which will have basically a video of the lab, okay, and results there, which you can use to write up the lab, okay. So you could also choose to do that. If you are here, then I would strongly suggest that you actually go to the lab and do it hands-on, because you'll learn a lot more and it's interesting, okay. But if you can't make it, then for various reasons, and there'll also be material on the LMS where you can look at the demonstrator doing the lab, and the results from that lab will be, or the files that they capture with the oscilloscope, etc., will be up on the LMS, and you can use those to write up the lab, okay, if you can't come to the lab itself, okay. Okay, again, PDF, etc. Okay, so for the lab and the project, okay, you'll need to use some simulation software for circuits, okay, and in the past we've used this OrCAD PSpice, okay. Last year we started using this public domain one, LTSpice, okay, which is something that you can install on your own PC. It's also been installed on the lab PCs, and you can find it in this directory, okay. There's also instructions on the LMS and some tutorial demonstrations done by the lab demonstrator on how to get running in LTSpice. Has anyone used LTSpice here? Yeah. So if you did 3021 last year, you probably used LTSpice, okay? Currently, we're still waiting on licenses for PSpice, okay? But, you know, it is a bit nicer to use PSpice. It's nicer setup. But to be honest, you know, you can do everything that you did in PSpice on LTSpice, and it's something you can have on your own computer, okay? You always have access to it. So I strongly suggest if you can, try and use the LTSpice, okay? I'm not sure if we'll get the PSpice licenses in time, okay? But LTSpice is there, and you should try and use it, okay? Now for plotting and processing results or solving equations, etc., on all the lab PCs there's MATLAB, okay? I'm not sure, I'll have to check if there's Octave. Now Octave, has anyone used Octave before? Yeah? So it's basically a public domain, free version of MATLAB, okay? So there's also... everyone has free access? Yes. Okay. But you got to go through that uni portal or whatever.
No. You just use your student email, they will be licensed.
Okay. Well, yeah. Okay, so you can use MATLAB. If you can't, then there's also this public domain Octave, okay, that you can use, okay. And there's a bit of a tutorial on the LMS on how to set that up if you want, okay. Okay, the computers in the computer lab 1.51, they've got those tools, and there's booked sessions for 4401. There's no fixed allocation, okay. You just go in, and providing there's there's spaces there, and there's no other students who aren't, well, provided if there's someone who isn't from 4401, then you kick them off and get a computer if you need it at that particular time. Okay, but basically it's first come, first served. You know, our experience is that there's always plenty of spaces. Okay, I think all this software is also available on all the PCs across the university. So I'm pretty sure that the image is the same, and so you could go to the library and get on a PC and also use these tools. Okay. Okay. So schedule of all the assessments due dates is on the LMS. Okay, check that for updates. But currently it's something like this. Okay, so we've got a quiz here in week 4, and then 2 weeks later we'll have another one just at the end. Okay, and sort of in the last week, Monday of last week, we'll have the lab report 1 will be due. Then you'll have a study break, and then lab report 2 will be due. And then we'll have the mid-sem, okay, just after you come back from this study break at the beginning of April, okay? Okay, so hopefully we'll finish all circuit theory stuff in this first half of the semester before you go on study break. And then just as you come back, the first lecture, we'll have the exam, okay? Okay, so it'll be 2 hours, okay? But we book a little bit longer so that you have about 10 or 15 minutes to get in and get out, etc. Okay? Okay, on the LMS, there's the unit schedule, unit coverage. There's copies of all the lecture slides in PDF, okay? There's also the course readers. So there's 2 little books that you can buy from the bookshop, okay? So they're written by this guy, Tony Cantoni, who's just retired, but he's been a professor here for a very long time, okay? And I'm not sure how much they cost. They're not very expensive, but if you want, you can get by them, and they're quite a useful reference. There's a lot more material in them than what will be covered in the course, okay? So these lectures are just a guide through all those notes, okay? Just picking out the important stuff, okay? So don't try and learn everything that's in there. You can if you want, but I wouldn't suggest it. But you can use the lectures and see where we're going, and if you want to have a full description of what's happening, okay, you can go to those notes, okay? And they're also useful for reference in the future, okay? So the one's called Part 1, Modelling Analysis of Electrical Networks, and the other one's Electromagnetism. Okay, so, and also there'll be PDFs of these up on the LMS. Okay, so you don't have to buy them, you can just download the PDF if you really want to, okay? Yeah, there's also some recommended reading. Okay, I think some of these are extra notes. Okay, if you want, perhaps, if those course readers aren't enough, then there's some other bits of notes here that you might find useful. Okay, you might want to copy them anyway if you do plan to do electrical engineering or electronic engineering. There might be something useful that you might find in your job. Okay, it's also library references. Okay. So, is there any questions on that at all? No? Okay. So now we'll start with the actual stuff itself. So this first part, we won't go through much detail today, but it could just be a bit of a review, a bit of introduction, okay? So the parts in the course reader, if you really want to follow them up. Okay, so this part of the unit is concerned, well actually the whole unit is concerned with using circuit theory and also electromagnetic theory to model and analyse electronic circuits and systems, okay? So to do that, we need to understand, the axioms. So axioms, if you had me in 3021 last year, the axioms are the truths of any theory, okay? So there's something that you assume to be true at the start of any theory, okay, that you're going to develop, okay? So they're truths that you take for granted, okay? And then you also have assumptions, okay? So when you start to apply that theory, okay, to particular circuits or elements or systems, then you're going to make some assumptions about those systems, okay, so that you can apply the theory, okay? So there's two things that we have to be clear about and understand when we apply circuit theory to design or analyse circuits, okay? Another point is that, you're not going to be doing, in your job, you probably won't be doing very much KCL, KVL manually, okay? You're always going to resort to computer analysis because the systems will just be too complex to analyse by hand, okay? But you have to be able to understand, the validity of the results that are produced by that computer design, and, are the assumptions that you've made to actually get the particular models for those elements that you're using in the circuit theory valid, okay, for your application. Okay? And how well the caveats required for circuit theory are applicable to the network that you have. Okay, so look at some examples. Okay, so in the past, we've been mostly looking at components that have just two terminals, okay? So typically a resistor is the component with just two terminals, okay? Capacitor, inductor, okay? That's mostly what we've looked at in the past, okay? But there's lots of components that have more terminals. Can someone give me an example of a three-terminal device? Anyone? Transistor, yeah, classic example of a three-terminal device, okay? And we looked at, just if you did the 3021 last year, we looked at two-port networks, okay? So, a two-port network is like a box with an input port that has two terminals, an output port that has two terminals, okay? But in this course, we're meant to be looking at components which might have multi-ports, okay? So many ports and also many terminals, okay? So multi-terminals, okay? And how they can be used to represent subsystems, okay? Okay? Initially, we just look in detail at two ports, okay? And a big part of this first part, okay, is modelling transmission lines, okay? So in the circuit theory that we did in 3021, we said that all the components are lumped, okay? So we said that all the dimensions in the particular circuit we're looking at are small in comparison with the wavelength of the signal of highest frequency of interest in that circuit, okay? So then we could apply those particular axioms to that particular circuit, okay? Okay. But in reality, in especially nowadays as things go faster and faster, okay, the frequencies of interest are very high, okay, and their wavelengths are small compared to the dimensions of the circuit, okay? So we can't just look at interconnections being just a simple wire, okay? We have to model them with something, and the thing we model them with is transmission lines, okay? So we've got to deal a lot with modelling of transmission lines. So a transmission line is something that is not a lumped element, okay? It's distributed. Its size is large in comparison to the wavelength of the frequencies of interest, okay? But we'll show that in the first part, we can use circuit theory itself to develop a model for a transmission line, which gives a description of it, which we can use in circuit theory to analyse systems where a transmission line is present using circuit theory and get the correct results, okay? So we will use circuit theory itself to actually develop a circuit theory model for a transmission line, and then we can handle these distributed systems, okay? As long as we connect terminals up correctly and assume that there's a transmission line between one port and another, okay? And we use the particular model, the circuit theory model for that transmission line. In the second part, we'll also look at using electromagnetic theory to obtain a model for transmission lines, okay? Okay, so we've already seen basic circuit theory. We use it to analyse networks of these components, okay? And we found that by using KVL and KCL, we could solve for all the unknowns in a particular circuit, okay? Providing we had enough initial information, okay? There's also something we'll be learning in this part of the course is called graph theory. Has anyone had any exposure to graph theory in computer science yet? No, no one. Okay. So so that's like an abstraction of the electrical network. It's used in lots of different areas like computer science, telecommunications. Okay, and we use that not to model the elements of the circuit themselves, but to actually model interconnection between the elements, okay? And so basically with graph theory, it captures the topological characteristics of a network, okay? So with graph theory, looking at a specific network, okay, you can use graph theory to derive general results about electrical networks, okay? So you can say, if a network just consists of RLC components, then all the particular unknowns in that circuit are going to have certain properties, okay? Okay, and you can derive those conclusions from graph theory, okay? And also, it gives a systematic way of being able to find all the equations that you need to solve for all the unknowns in a particular circuit, okay? So if you have a very large circuit with lots of components, okay, how would you write down all the particular node or mesh equations, etc., and make sure that you can solve it properly, okay? So graph theory gives you the basic methods to be able to do that, okay? Okay, and to solve them in a consistent way, okay? To obtain those equations consistently, to know exactly how many unknowns you need to solve for, and to actually put it into a matrix form where you can use standard methods for solving linear systems to actually get all the particular variables that you want, okay? So graph theory, or those methods of putting it in a particular form, are what things like SPICE, the simulators, use to actually solve for particular variables and simulate a particular network, okay? So we'll go through graph theory, and we will we'll look at applying it to RLC networks, and we'll probably just have in the exam or in quizzes or something, you'll be asked to write down the equations, etc., for particular networks, etc. Okay, in these particular standard forms that can be used to solve for variables. Okay. Okay, what electrical paradigms do we bring to bear to help us analyse networks of electrical components we find in electrical systems? Okay. So, can anyone name some of these basic theories that we use to describe the components? Okay, so when we have like a resistor or capacitor or something like that, we have a model for it. So if you did 3021 last year, we had a model for a resistor, a model for a capacitor. Can anyone name some of the actual basic physics or physical theories that go behind some of those models? Anyone?
There's a current and voltage associated with each component.
Sorry?
There's a current and voltage associated with each component.
Yeah, but so for instance, for a resistor, we get the current's related to voltage in a certain relationship, right? So how did we get that? What theory would, in physics, did you do any theories that related current to electric field in conductors? Anyone?
Like the relation between the two.
Sorry?
The relation between the two, you mean?
Yeah. So the model for a resistor is... Yeah, that's right. So where does that come from? That's what I was asking. That is Ohm's law, but that's true. But that's a good point. I mean, no, that's great. I mean, but Ohm's law comes from somewhere, and if you did basic physics, you might have heard of Drude model or free electron model for conductors or something. So in a piece of metal, there's 3 electrons, okay, and basically when you apply electric field to them, the drift of those 3 electrons changes a bit, so they start drifting in one direction overall, and they have certain collisions with the atomic lattice, and it's those frequency of those collisions which determine how much current is going through depending on the electric field, okay? So that gives you what R is, okay? So for a resistor, I suppose the paradigm that's used, okay, is solid state physics and in particular 3 electron model and Drude law. For a transistor, perhaps, for a transistor, we have a model for a transistor which consists of, mostly, resistors, capacitors, and dependent current sources, okay? And that comes from, where does that come from? Anyone? Did anyone do 3014? Yeah, that's right. So it comes from PNP junctions, or diode junctions, but it comes from semiconductor physics, right? So that's one of the paradigms, okay? So these are the sort of things that we use to generate models for electrical components, okay? So the one we'll be interested in here, the paradigm for this course, which we'll go into more in the second half of the course, is electromagnetic theory, okay? So electromagnetic theory will supply us models for things like antennas, transmission lines, waveguides, okay? So that's a new paradigm. I don't know if you've done much on EMT yet, but that's what we'll be doing in the second part, okay? Okay, so far you've learnt what circuit theory for lumped RLC elements, okay? So we should remember what lumped is, okay? But it means something is, for the interconnection and the components themselves are small compared to the wavelength of the highest frequency of interest in the circuit, okay, and you can represent interconnection by wires which have zero delay, okay. Okay, so we'll just go through these three outcomes, and then we'll end it up for the day, and we'll start tomorrow on a bit more of the detailed stuff, though it's still a bit of revision. Okay, so for this part one, that you really should try and have, well, hopefully at the end there'll be three key outcomes, okay? A clear understanding of the concepts of abstraction, modelling and approximation, okay? When you're applying that to analysis of electrical circuits, okay? Under that, you should be able to identify various abstractions, okay? Discuss the key characteristics, and identify critical axioms and assumptions, okay? Explain the nature of the approximation involved when you have to apply them to physical systems. Another important outcome is to appreciate the role of multi-port networks in modelling and analysis of electrical systems, and also applying that to transmission lines, okay, and two-port electronic circuits, okay. And so you need to be able to describe how, and you will go through a lot of differential equations, show how it works, okay. Describe how two more models can be obtained for transmission line segments, okay, and how eventually that can be made into a total transmission line, and also two-port electronic circuits such as amplifiers. Formulate network equations for interconnected multi-port networks and network functions of interest such as impedance transfer, impedance and voltage gain. And the final part is to do with graph theory, okay? So you've just got to be aware of what basic digraphs are, okay? So we're going to go through that. You should be able to understand and use key results in network theory applied to linear time invariance RLC networks, okay? And also how to derive these things we call the tableau equations, which you can use to systematically find all voltages and currents in a particular circuit. Okay, so that's the overview of part one. Okay, so is there any questions before we go? Anyone? Okay, thanks. Well, I'll see you tomorrow, and we'll start on the more detailed stuff.